to be protected. That's how we have non-IBM processors, because they reverse engineered IBM processors back in the 80s, and Intel started making their own, right?
Oh, oh, okay.
Right.
Okay. But then what you do with the data that you get from the API, that's a different thing.
Yeah, I mean, that's a, I'm not a lawyer, so I don't know.
Yeah.
But reverse engineering is always protected.
Oh, okay.
That's why APIs aren't, or I mean, the legal argument that should prevail is that APIs aren't copyrightable because they're public, and you can the thing that actually required work is the implementation of the API, and you can always reverse engineer that, right? The API itself, you can always just use the API and implement it. That's the legal argument. But today we're going to be using an API, a Jdbc API. The goal is to programmatically connect to our database through Java, because of course, and I should have it up here, but MySQL Workbench is basically just an IDE that allows you to non-programmatically connect manually, basically, to your database. Let's see. 4156. There we go. All right, I'll bring this over here. And what we're going to do is we're going to use the database that we designed last week, with the film actor, a director, et cetera, et cetera. And remember that a film is defined to be an ID and a bunch of other things, okay? So what we're going to do is we're going to connect programmatically to this database through Java code, pull data, and just display it for now. But of course, you can go ahead and persist the data as well, save it, do number crunching, et cetera. So basically, instead of reading from your CSV files, ultimately you'll be reading from your database and then persisting or saving to your database. Most languages have some support for database connectivity. I don't know, or at least a library that you can bring in. There's very few actual languages that I know of that wouldn't connect to a database in some way, okay? And for Java, that's going to be JDBC, or Java Database Connectivity API. JDBC is equal to this, right? And so BC, or DB, excuse me, is just going to be database, even though it's technically one word, right? An API, like you said, is an application programmer interface. And this is a perfect illustration of the D in the solid principles. Remember that that's the dependency inversion, that where you shouldn't have high-level components depending on low-level components. The high-level component in this case is going to be our Java code that connects to the low-level component, a database. If we instead wrote towards a specific database, we had like connect to MySQL database, query MySQL database, process MySQL database, right? Then that's a dependency that ties us to that database. Dependency inversion in this case means separating those out and putting something in between, an API. So that instead of connecting to a MySQL database, we connect to a database, right? And that's the API that is in between these two things now. The driver over here implements that API, so that what we can do is we can just write code to connect to a database. I didn't specify MySQL, I didn't specify Postgres. Instead, we drop in a jar file that represents a driver for that particular database. We go over to Postgres, fine, just take this driver, throw it away, plug in a new one. We didn't touch a single line of code over here because we were programming towards the API, right? The dependency inversion. And that's a perfect illustration of the D in the solid principles. We don't program towards a specific database, we program towards a generic interface, and then ultimately it's not our responsibility to make this thing over here. Instead, vendors, that is people who sell these database systems, Oracle, IBM, they provide a driver to you to use. Yeah?
So it's sort of like how in the last lab we had like songs and we had albums, and we had album and song in the middle.
That's a little bit different in that it's a join table bringing together to making a relationship. I mean, graphically, it kind of looks the same in that you're taking two things and putting something in between, but you've actually stumbled upon a universal truth that everything is a graph. And so that's the only connection there, that it looks similar when you graph it out, right? Why is everything a graph? Because everything is a relation. There are things, and then there are relations between things, right? And so everything can be modeled by a directed graph. And that's why graph theory is so important. Hopefully you'll get you're maybe not there in 235 yet, but at least you'll be introduced to graph theory, all right? At some point. Let's see. So instead of programming towards like a particular connection, etc., we program towards a generic connection. We use what are called prepared statements. They do have other types of statements. I'm not even going to show them to you because you should never use them. That is a perfect attack vector for what are called SQL injection attacks that allow attackers to execute arbitrary SQL code. If you use a prepared statement, you protect yourself against those things. And then finally, a result set. If we're querying a database, we expect results back from the database. That's called a result set, right? And it's a set because, just like a database, it's unordered, right? The ordering doesn't matter. The ordering of columns doesn't matter. It's a set that we can then iterate over. I've mentioned them before, but and you've asked them about them before, I think. ORMs, we're not going to get into that this year. If you want, there is a video about it. I think 3.9 goes over JPA, and then there's a bonus extra lab 10.5 available that shows you how to use JPA. If you want to use JPA for your projects, go ahead, be my guest. It's just got to work on the grader. If you want some pointers on troubleshooting it and getting it to work that way, let me know and stop by office hours and we can work through it. But JPA or Juke are ORMs, which are object relational mappings. It basically allows you to annotate your classes and say that this class is associated with this table. This column is associated, this variable in the class is associated with this column in the table. You write the JDBC code for me, right? All you have to do is do those simple annotations, and then you don't have to write a single line of CRUD, create, retrieve, update, and destroy. Right? But we will be writing a lot of CRUD today in this demonstration. So let me give myself some more room here. There. All right, so the first step is, of course, the setup. You download the driver, and this driver. This is the connector J driver from Oracle. Right? And to do that, I've just got my web DuckDuckGo up here. If you just search for connector J, the first one that pops up is dev.mysql.com. You, of course, can download a platform independent. If you want the source code, you can grab that, and then you can download the zip file here. I've already done that. Just a fair word of warning here. They want you to sign in and create an Oracle account so that they can spam you. No thanks, just start my download. Right? Just click there and you're done. Right? You'll get a zip file with a jar in it. The latest version as of today is 8.0.23. I dropped that into my lib folder. I added it to my build path, and now I'm ready to go. So I've got this load data class here. What I ultimately want to do is I want to connect to the database, and ultimately I want to process film and director data, and then eventually, maybe next week, I want to persist or save film and director data. Okay. So I've created a class over here to load the data. Now, you might think, well, wait a second, if we're loading directors, that's a director thing. Maybe it belongs in the director class. Or if we're loading up actors, then that's an actor thing. That belongs in the actor class, or likewise the film. You can follow that pattern, but very, very quickly you'll realize how big these classes start to get. What's to stop you from going back and, loading up an actor from a CSV file, that's an actor thing. I'll go ahead and throw that in there. Loading it up from an XML file. that's an actor thing. I'll throw that in there, right? And then just because there are various data formats that you can load and persist to doesn't necessarily mean that that stuff belongs in that class, right? That seems like a separate thing, an ancillary thing. Yeah, it's an actor thing, or a film thing, but it's a film loading thing. So let's put that somewhere else, right? And the way that I've put it over here is I just have this load data class, okay? So what I want to do is I want to load up all of the films that I have over here. So I've described films. Let's go ahead and select everything from film. Right? And we see those 3 films that we created last week: Eraserhead, Hateful Eight, and Star Trek 90210. Right? With various information. The way that I've modeled it over here in my Java files, I've simplified it a little bit. I'm only pulling the ID, the title, and the director. And the director here is not a string. It's not an integer, the director ID. It is the object. Right? So what am I going to have to do in order to get that information if I want the first name and the last name? I'm going to have to join, right? Join director, ... All right? We'll eventually get there. Select everything from film. And now, I've got stuff in the database already, so now I've got basically a test case that I know what's in there. Eventually, when I write my Java code over here, I know what to expect, these 3 films with those 3 names, okay? So I want to pull all film data, films, . So should I start immediately writing JDBC code to connect? Or does this seem like a useful kind of functionality? And if you think that it's a useful functionality, what should you do with that functionality? Put it into a function, right? Or a method, as far as Java is concerned. So public, static, and we'll return a list, say, of film objects, right? Get all films. There. Now, once we have that, then of course we can pull them all, we can call it in our main here, films is equal to get all films, and then we can of course print them out. For film F in the collection films, then system.out.println F. There we go. Import. And yeah, there, good. I'll start off by creating that list and then returning it immediately, and then we'll fill in the gaps as we go along. So list of films, result is equal to new array list, and we'll return the result. There. Import, done, okay? So now I will go back over the notes here, and here's the basic process. The first step, and I'm going to label this as 0 like I did in the earlier section, is load the JDBC driver. Right? This is an artifact of old school Java, so this is archaic, would be the word, right? And it's probably optional, especially if you are using a newer Java. If you're using really, really old Java for some reason, I don't know why you would be, but you do have to do this step in old Java, okay? And what it looks like is it looks something like this, right? Where I'm going to grab this, move it down here, just a second, bear with me. Here is the loading of the JDBC driver. And let me uncomment all of this so you can see what it looks like. Relabel this as 0. Load the JDBC driver. This is the driver class. This is a fully qualified package name. And you see com for commercial, MySQL for MySQL package, CJ for connector J, JDBC, and then the driver is the class that we're actually loading up. That's the thing that's provided by Oracle in this case, or by your vendor in general. That driver class, then you can load it up with a new instance so that Java, the Java virtual machine, is aware that there's this driver that exists out there. This is old school Java, right? You don't need to do this anymore. Right? as long as you are using Java, I believe 8 or 9 or later, then this is not a necessary step. Okay. I do mention it though simply because you will see tutorials. If you search around for JDBC tutorials, nobody's updated their tutorials for 10 years. So you'll see that this first step and you go, oh, wow, that seems tedious, and it is. You don't have to do that anymore. Okay. So the next step after you do that, and that's why I label it as 0, is to make a connection to your database. Right? And what do you need to make a connection? You need a URL, a username, and a password. So here's my information. So make your connection. I'm going to put them into this URL string, this username, and this password. And then once I've done that, I can create a connection. Connection, con, is equal to new connection. Passing in the URL, the username, and the password. Now, it's going to complain for various reasons. Don't worry, we'll get there. But that's a really long URL. That's not needed in general. That's just what you need to connect to CSE because of our configurations. If you were connecting to a different database, you might actually have an even longer URL, or you might be able to simplify it based on their configurations. Don't worry about it. I'm going to put this in the notes, of course, and the labs will also have this connection string. Right? And who knows, they might, I tested it already, so it still works, but they might have updated their configuration so that some of the stuff's not necessary anymore. Go ahead and troubleshoot at your leisure. Yeah?
Is it like some sort of flags that you mark?
Yeah, these are all parameters. So use Unicode true, right? And then the next parameter, these are URL parameters. So like any web address in your browser, you separate them with ampersands. The next one is use JDBC compliance time zone shift true. Because they've got a weird time zone set up on CSE for some reason. Use legacy date time code false. Server time zone UTC. I have no idea why they set their user time zone to UTC. UTC is universal time code. I mean, no. Well, no. I think it's whatever is at the prime meridian. In England? What? Greenwich Mean Time. There we go. Greenwich Mean Time, or UTC to take out the Greenwich in there. But anyway, what's important to you is you have to update the login there. You can't use my login. Right? Update your username to your username, and update your database password to your database password. Remember, we told you don't use a password that you care about, right? And this is why. Eventually, you will be embedding it in your Java source code, so your partner will know about it if you have a partner. The LAs will know about it. I'll know about it simply because we'll see your source code when we grade it. So don't use a password that you care about. Yeah?
What password is that again? 'Cause, like,
Whatever you've been using over here in MySQL Workbench.
Okay.
If you need to reset it, you can go to csc.unl.edu/accounts, and a new hexadecimal password will be sent out to you, randomly generated.
Oh, well, it's randomly generated.
Yeah, and if you look at the system fact, there is a way that you can set it to whatever you want. In fact, you don't need to look at the system fact. Set password equal to password. That is a function call, and then 1234 is my new password, right? As a string. I'm not going to do that, of course, but you can execute that and it'll reset your password in MySQL Workbench.
Okay.
Right? Again, do not use something that you care about. Right? It's not that bad that people know my password right now, because the worst that you could do is drop my tables or insert some USUC data or something like that. Go ahead, if you're watching at home, go ahead and try it. Insert a USUC movie or something while we're waiting here. Yeah, go ahead. No? Okay.
You're okay with someone just dropping your tables like that?
Well, I can always recreate them. I've got the scripts.
Oh, okay.
That's why you write out everything in your SQL scripts. You don't just, create it and then throw stuff away, right? You can always recreate it and recreate it as many times as you want. In fact, there was a question on Piazza, what does it mean it's clearing out the database? Well, it's clearing out the database. It drops all the tables and then it recreates them so that every time it runs the grader, you have a fresh snapshot of the database. If we didn't, then 100 other students insert garbage data, or they insert Nirvana's album 50 times, right? Then you're dealing with a different snapshot every time you run it. So we clear out the database, right? The worst that could happen is somebody drops our tables and I'll just have to recreate them really quick. Right? So it's complaining right now because, oops, did I? Nope. I did import this new connection. Oh, sorry, that's not how you create a new connection. You can't call a constructor on this. Instead, it follows a different pattern. It follows a factory pattern. Let me go ahead and get rid of this. There we go. And there we go. So the driver manager is responsible for creating connections based on your URL, your username, and your password. Let me go ahead and import this, and it still won't work because it's going to, well, because I got rid of it. Connection con equals null. There we go. Now it'll complain about this. It's going to it's throwing what's called, remember, a checked exception. So let me surround this with a try catch. Remember that a checked exception is one of those exceptions that forces you to catch it and do something with it. Okay? Lots of stuff could go wrong here. I could have gotten the URL wrong. I could have a bad password. I may not have, the server could be down. Right? I could have a misspelled username, right? A million things could go wrong here. I might not have a network connection, the server could be down, etc. There's no reasonable way to recover from any of those things, especially if this is deployed to a production server, right? So why is it a checked exception? And you see that they violated their own, or Java, in putting this in, they violated their own design principles when they did this. They said that when they created checked exceptions, the ones that you have to surround with a try-catch, they said if you can reasonably recover from the error, then you should always use a checked exception. There's no reasonable recovery from any of those things that I mentioned, right? So we're forced to deal with a 20-year-old mistake. How do we deal with it? We rethrow it as a runtime exception. Remember I called this catch and release? Just like a fish that you catch and then you don't intend to eat, so you release it, right? Actual anglers will fill them up with antibiotics too, so that they can get bigger, right? Or they give somebody else a chance to catch the fish. So runtime exception, we catch it, we release it, and we throw it and make sure that it becomes fatal. You'll see here that it'll probably actually run, but it won't do anything, of course. But it'll successfully run because everything up here is correct. If I have a bad password, you can see that it'll throw this message, access denied. You were using the password, yes, but it's not going to tell you that the password was wrong. I'll misspell my name, right? And access denied. Using password, yes, because it's not going to tell me that there's a difference between a bad password and a bad user name, because that's leaking information, right? You could get a positive result back saying, yes, in fact, this user exists. Oh, okay, now I just have to guess their password, right? You don't want to tell them anything useful like that. You could have a bad URL. There is no such thing as the server cs.unl.edu. And now it's going and spinning its wheels with the network and the DNS server, asking, where is this server? Gee, I don't know. Let me ask that DNS server. Gee, I don't know, because there is no such server. So I'm going to go ahead and stop this. Eventually, it will time out. There is an actual server, CSCE, right? That's a real server, but there is no SQL database sitting there listening on port 3306 there, or at least it's firewalled out. And so it's going to say communication link failure because it's probably actually firewalled. I'm sure that there is a database server there on 3306, but we're not allowed to connect to it. Right? So millions of things could go wrong, right? And they all throw the same exact exception, SQL exception. Right? How can you reasonably recover when a million things could be represented by one? Right? I don't know. Right? But it's something that you have to do. You know what? This seems so standard that if you're going to do this every time you need to make a connection, don't repeat yourself. DRY, where should you put this kind of stuff? Maybe a function. We call those things factory functions, right? And so that you can reuse it over and over again. But anyway, step 2. Formulate your query. Now, queries are simply just strings with SQL code inside of it, right? So I'm going to go over here to my SQL workbench and troubleshoot the query that I want to run, okay? I want to pull all film data, but also the director data, the first name, last name, etc. So I will join film to director D on f dot film ID equals, or not film ID, director ID, D dot director ID. And as long as it works in my SQL workbench, then I know that I've got good syntax. I know that it's actually querying the correct tables. Yep, that looks right. That looks right. So I will go ahead and copy pasta over here into Java. Right? It's just one big giant string. One thing that you can think about is, do you need this semicolon? No, not technically, since it'll execute the query and be done with it. I like to leave them in there just because that copy pasting back and forth, you'll either have to add it or get rid of it and be consistent about it. Right? It's a rather long query. You can go ahead and break it up over multiple lines if you want to. It'll automatically concatenate it for you. I'll leave it as is. Yeah?
How do you do it like that? Because when I tried to do something like that, and
Like
it's
enter?
Just like, yeah.
It's got to be a valid string to begin with, but otherwise just somewhere inside, just hit enter to go to the next line.
Oh, it has to be a valid string.
Yeah, you can't, it has to be closed and valid string. Now, oh yeah, go ahead. A string, well, the appending is just syntactic sugar. When you do something like this, the Java compiler will actually take all your pluses and throw them out and use a string builder. And it replaces your code with string builder .append everywhere. And so it's just syntactic sugar. There really is no, at the Java bytecode level, there really is no concatenation operation. It's all just a bunch of method calls. No, I mean, a lot of people stylistically like using string builder directly because they know it's going to be replaced anyway, but why are you throwing out the syntactic sugar? I've got a sweet tooth. I like using it, right? But it's no more or less efficient. Because it all goes away at compile time. Right? Another stylistic thing here is you do not have syntax highlighting when you just throw it all into a string. So some people like going to the old school SQL of select from, and now visually it pops out a little bit more than the other stuff. It's all monochromatic, so you're back at the old green screen days, and you might have a desire to use that. I don't really care personally. As long as you're consistent about it, that's what we care about as far as grading goes. I can read it just fine without that stuff. That's just me though. Some people like using the all caps style. Yeah.
Is there something like this morning while I was browsing through the Eclipse marketplace for the UML thing, I found like there was like a dark mode thing for Eclipse.
Mm-hmm.
I was wondering, is there something like
Oh, I'm sure.
just like that but for queries, but like
Dark mode.
it would like do the highlighting thing for certain words?
Oh, I'm sure. If you search around for it, I'm sure there's a plugin for it that will syntax highlight within a string as long as it's context to SQL code. I'm sure. If not, you can write one and then put it on the Eclipse marketplace and be famous. That will not get you any fame. Generally, you do not want fame.
That's true.
Because then you get just randos on the internet contacting you for every little thing. Like probably the oldest piece of software that is actually used that I published was a LaTeX complexity package. And that was a good 15, 20 years ago. And I still get the occasional yearly email from people saying, how do you do this? Like, or I'm not going to give you troubleshooting. And then only very rarely, since it's a mature package, will I get people saying, I have this feature request. There was actually a feature request like a year or two ago. Well, yeah, that's a pretty good request there. I can't deny that. But I had to pull out this 10-year-old code, and I had to clean it up, and I had to do a bunch of other, every time you look at code that you wrote 10 years ago, you'll be like, why the hell did I do that? And then you'll want to clean it up and fix it, and I had to do it. And then it's not like it's a continuous integration process with LaTeX. You had to like give it to somebody, and then it was a back and forth over a couple of weeks because, well, we want you to do this, like we want you to have the README file in this shape, et cetera, et cetera. All right, fine. It was a pretty involved process to get this in, finally into there. But every LaTeX distribution has my code in it. And so, of course, I mean, you understand their gatekeeping, that they want everything to be as clean as possible because so many people use it. But at the same time, my name's on it, and so I'm the one that people contact when they have a question about the complexity package in LaTeX. So you don't necessarily want to be, that's fame, but that's more fame than I want. All right, so there's our query. We're going to pull that stuff out. When I look at it in MySQL Workbench here, though, remember that I don't care about the EIDR. And certainly, I've got director ID here twice, right? Think about what this is doing. This is sending all this data over a wire. The network is still the bottleneck for the vast majority of applications, right? The processor speed is not that big of a concern anymore because they're so damn fast. What is a concern is sending a bunch of data over the wire because network, especially in the United States, is still garbage, right? Even a high-speed network, you still want to be cognizant of sending superfluous data or data that you don't care about. Since we're not using this, we shouldn't be sending it over the wire. Right? Instead, we should be far more intentional about this. Right? We should be only getting the film ID, the title, what else do we want? We do want the director ID, right? And we do want the director last name and the first name. Before we copy pasta this over, let's make sure that it works. It doesn't. Why? I've got 2 director IDs. Which one do you want? D.director ID. Doesn't matter. Right? There we go. Oh, and then, thank you. No comma. I did that same mistake this morning. Why does it work? It's an alias. Remember that the as keyword is optional. So when I do it like this, it's using it as an alias. There we go. This is why we troubleshoot in this environment and then bring it over when we're done. All right? Looks good. Let's bring it now, if I were to bring this over, it's not going to manifest itself with this particular data, but Quentin Tarantino has directed 8, 9, 10 films. If I pulled this data like it is right now, I would have Quentin Tarantino repeated 8, 9, 10 times. Should I send that redundant data over the network? I probably don't want to do that. So let's go ahead and not do that, and we'll figure out another solution. All right? For now, I'll just pull not everything, not star, but I will pull the film ID, the title, and the director ID from the film table and not have to worry about the the director table yet. Right? So from film and be done with it. Now I was editing over here. I think it's correct, but you're not going to be able to troubleshoot SQL code in your Java files. So bring it back over here, see if it works. Ah, no, it doesn't. Select extra comma. There we go. Now it's troubleshooted. Troubleshot. Nobody ever says troubleshot or troubleshooted. You troubleshoot something and then it's fixed. All right. So there's my query. But the next thing I need to do is I need to create a prepared statement and a result set. And for that, I'm just going to create these. Initially, they're going to be null. And then I'm going to, of course, I'm going to have to bring them in. And at this point, I would point out to you that if you have a choice, if you bring in anything else like com.mysql.cj.jdbc.connection, that's wrong. Now you're programming level module. You're not programming towards this generic API. All the generic API stuff is over here. Uh-oh. We are doing terrible on our live stream. Hopefully not then, sorry. But you can watch the, I'll post the, a link to the other video. All right? Anyway.
The server connections here were awful.
Yeah, well, it's because they changed over to that new network infrastructure. And thing and do it over a summer. Let's do it in the middle of classes. All right? And let's do it in the middle of a COVID crisis where they're all being broadcast. Right? So, anyway, my prepared statement here, I just call it PS and RS because there's really nothing more specific, right? Now, if you have multiple prepared statements, the pattern I'll see is like PS1, PS2, PS3, or RS1, RS2. Find a more descriptive name, otherwise you're going to lose. All right? Con.prepare statement. And the query is what I want to prepare. Okay? Now I'm going to execute your query. When I execute this query, I expect a result set back. So I'm going to capture that into the result set, ps.execute query. That returns the result set. Now this result set is exactly like it's depicted over here. There are 3 elements. I want to iterate over each one of those elements. Initially, what I've got is a cursor that points before the first element. Then what I can do is I can hit, this has 2 effects. First of all, it advances this cursor to the first record, and then it returns true. I am pointing to a valid record. If I do this again, rs.next, it goes to the next record and returns true. rs.next, third record, returns true. This is still a valid record. rs.next goes past the result set and returns false. There's no longer anything for me to process. So I can put this into a pattern with a while loop. And each iteration of this while loop, I'm pointing to the current record. Okay? And I can process each column in that current record. Now, I'm only expecting these 3 columns, so I can pull them out directly. Int film ID is equal to rs.get film ID. And I'm naming my variable after the column name. And when I put that into the film class here, following the modern naming convention of upper camel casing for tables, lower camel casing for column names, because it matches my Java style. Right? And I don't have to have any guesswork here at all. Now, get will not work, but it is an integer, so get it as an integer. Right? If I got this as a string, it'd be kind of weird, right? Because it's an integer. But if it is a string like the title, string title, rs title. There we go. And finally, the director ID. rs.getInt direct ID. There we go. No guesswork at all. Right? Now I can create my object. Film f is equal to new film. Passing in the film ID, the title, and the director ID. I wonder if or not this, but results.add f. Right? And eventually I will return it. Results. I should have called it results, right? There has been some confusion with the grading on when you can pluralize the method name. That's fine because it returns films. A result set, or it contains results. It's okay to pluralize method names, variable names, but you never pluralize classes because classes are blueprints, right? I don't think that there's anything. Is there datas? Data is already the pluralization of data. So again, that's why we don't pluralize, because English is stupid and weird, right? Okay, so that's not going to work because I don't have a director. I only have a director ID. If you take a look at the way that I've modeled this, I've modeled it correctly, right? A director is not a string, a name. A director is not an integer, a code or ID or something like that. A director is a director or a person or something, right? So I now need to rectify that problem that originally we were joining, but then we said, we're going to send Quentin Tarantino 10 times on every single query here, on every single result. So now I can make another query here. Rather than joining directly, I can make a separate query and get Quentin Tarantino from this director. Should I do it right here? Question mark is what I wanted. Should I open up another connection right here? Well, first of all, that's stupid. I could just reuse the connection. I would need to make a new prepared statement and a new result set. But that sounds kind of useful. A way of, I've got a director ID. I want to pull that from the database. If it has use beyond just one place, what should I do? Make it a method, right? So let's come back up over here and make it a method. Public director, it's public static director. Get director by ID, right? Because of course you could get director by name, get director by code, right? Get director by whatever, right? And you might want, the ability to do multiple database polls based on different criteria. In this case, though, it's going to be get director by ID, int director ID, right? And right now, I'll just return null so that it actually compiles, and let's move on, right? Remember, always leave yourself to do. Implement this. And you don't even have to spell it correctly, because of course you'll come back, do it, and then erase that to do, right? Yeah?
For our projects, don't we have two sort of IDs for things?
You'll have a code, which is which is a natural key, and then you'll have an ID, which is a surrogate key, right? Then that's going to be your primary key. So anything internal to the database, you would use this primary key, right? The surrogate key. If you have something external, then you would use the code, right? They would both need to be keys, probably. They would both need to be codes. Whether or not you write a function for every single combination, that's a design decision up to you, right? I would say, again, take the Yagni approach. Don't just write everything, right? As you're writing something and you realize, man, it would sure be useful to have a get director by ID function, then write it, right? But don't say, oh, I need to get a director by ID and code and this and this and this. I'll write all these things first, end up not using any of them, right?
So we could potentially do it just by ID and not need the code?
Potentially, yeah. Well, look ahead to phase 5. You'll need the code. Don't get rid of the code. So director, get director by ID, and I'll pass in the director ID. Right? And once I've got that, I can just pass that into my constructor, and everything's fixed. Right? Now, it's complaining here because everything in the Jdbc library or API throws an SQL exception checked that you have to catch and rethrow. All right, before we return our results here, let me go ahead and show you something. Thread.sleep for 1 minute is all I need. So 60,000 milliseconds. That sounds like a lot, but that's just 60 seconds. Surround this with a try-catch. The only reason I'm doing this is so that it won't just immediately execute. Right? Let's go ahead and run this. All right? Now it ran everything, and then it got to this point, and now it's asleep. Let's take a look over here on the server. Show process list. There's my process that connected to the database and is now sleeping. Right? Run this again. It's been sleeping for 10 seconds. Now it's been sleeping for 21 seconds. Now 24 seconds. Right? What is it doing? Now I've made it go to sleep intentionally because once the program ends, everything gets cleaned up already for me. But what if the program didn't end? What if I go and start processing other things? What if it's a long-term program that's running on a server and it never actually ends? What about this connection? It's still alive. Still alive, right? And it's alive forever, right? Again, I'm just simulating this for 1 minute. What if it stays alive forever? Right? It's taking up resources. It's taking up memory. It's taking up bandwidth because messages are being sent back and forth saying, stay alive, stay alive. Okay, I'm still alive, stay alive. Now there is a timeout in most servers. On the CSE server, there's a timeout of 5 minutes. That if you do hold on to a connection for over 5 minutes, then it eventually will be, without making an actual query, just staying alive, it'll actually kill it. Not only that, but if you open up 30 connections and then try to open up the 31st connection, nope. You are limited to 30 persistent connections. So what did I not do? I didn't clean up after myself. And by the way, now it's done executing, so if I run this, you'll of course just see the two. This is my SQL workbench, and then this is the query that I just ran to show all the processes. Right? What did I not do? I need to clean up my resources. So this was step 2, formulate your query, execute your query, process the results. And then finally, clean up. Right? I'm going to go ahead and close my result set. I'm going to close my process, my prepared statement. And I'm going to close my connection. Now, if I had additional things to do after this, like another query, then don't close your connection. Making a connection is actually really, really expensive. The original handshake that you fire up when you connect to verify your password, the back and forth, all that actually is quite expensive. And a common pattern that you'll see is what's called a connection pool. Immediately open up 30 connections and pay for them once. Then put them in a pool over here that keeps them alive. Every time you need a connection, you check it out like a library book. Once you're done with it, you don't close it, you put it back into the pool. That's called a connection pool. So that you're not paying for the connection and disconnection every single time you want a connection. If you want to do that, implement that, go right ahead. You'll need to make sure that it's synchronous though. Right? And it's not worth bonus points. But it is a nice little fun exercise if you want to get into it. Why did I close them in that order? Why did I go result set, prepared statement, connection? Because that's the order that I opened them in, right? The connection, 99 times out of 100, simply closing the connection, it'll clean up everything for you. Again, it's like file I/O. 99 times out of 100, not closing a file will be okay. It's that one time out of 100 that it's not okay that it ends up coming to bite you, right? So always make sure that you're closing these things and closing them in an order here. Not only that, but some APIs don't do that for you. You close the connection and it'll leave everything else open because it's not a very well implemented driver. Earlier versions of the connector J didn't do it for you. Most recent versions I think do, but it's still a risk. Don't risk it. Write interoperable code. And now when I do this, you won't see it because it was ephemeral. It only took a few milliseconds, but I closed everything up. Also, we don't have our director information here. Why? Because it's returning null. So let's implement that now, right? With the remainder of our time here. So again, you don't have to do step 0. Step 1, make your connection. Copy pasta. Copy pasta is a huge red flag too. Maybe I should be putting that into a separate function and reusing it. Right? Make your formulate your query. I'll copy pasta up to this point. There we go. Formulate your query. I'm not going to select the film ID, the director ID, etc. What do I want now? Let's go back to my SQL workbench and work on this. I want everything from director where a director ID is equal to, say, 1 for Quentin Tarantino, right? So should I be doing everything? Why would I query the director ID when that's what I gave you to query for the record, right? Let's be more intentional about this. Last name, first name, oops, comma first name. There we go. That looks good. Let's copy paste that over here into our query. Is that going to work? For Quentin Tarantino, now he's directed everything, including that Star Trek movie, right? Nope. Here is a classic beginner mistake. Never, ever, ever do this. Director ID. What did I just do? I used string concatenation. Never do that. We are using prepared statements that ultimately sanitize your SQL statements. If you use simple string concatenation, and you say that you're pulling stuff in from a web form where anybody is allowed to type in whatever they wanted, they can do what's called an SQL injection. Knowing that bad websites will simply use string concatenation, instead of entering my name or my login ID, I could enter in some SQL code that allows me to gain access to your system, gain information from your system, or just be malicious and drop all the tables. Right? In fact, this is a classic XKCD. I think I put it somewhere, but XKCD Bobby tables. There we go. There, exploits of a mom. So here's an illustration of a classic SQL injection attack. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert, apostrophe, end that SQL statement, drop table students? Oh yes, little Bobby Tables we call him. Well, we've lost all this year's students' records, and I hope you've learned to sanitize your database inputs. Right? What the school was doing in this instance was something very, very stupid. They were using simple string concatenation to do all their SQL queries. Don't do that. But we do need a way of parameterizing this so that I can put that director ID in there rather than just hard coding it to 1. I don't know what it is, so I'll put a question mark in. Question mark is a special symbol that can then be replaced with sanitized data by the prepared statement. So I'll go ahead and prepare my statement, but before I execute it, I need to set the parameters. Right? Now there's only one parameter in this case, but if there were multiple parameters, then there would be multiple question mark, question mark, question mark. If there were 5 of them, 5 parameters, you would index them 1, 2, 3, 4, 5. Unfortunately, it is 1 indexed, and there are no named parameters. Some systems allow you to do that, not JDBC. And so the order matters. If you want to set the first one, it's 1. Second one, 2. Third one, 3, etc. And the way that you do this is simply just set them. It's going to be an integer, right? So set the first parameter as an integer using this value, the value stored in this variable, director ID. There. In fact, statements like this, if you were doing batch statements where you had to reset the parameterization, you can just reset it, go into a loop and set it on each loop and then execute your query if you were doing insert statements or something. Right? That sets this question mark here to whatever value is stored in this variable. Yeah?
If it was only an integer that was put in there because it's an ID.
Yeah, that's not that risky for an integer, but it's definitely risky for strings. And it's not that risky for integers, but it's still risky for integers because you could inject, information can be encoded in an integer. So if you knew that there was some byte sequence that it couldn't handle when it ended up being string concatenation, you could get away with some things, right? Potentially. Right? Never risk it. Oh, it's just an integer. Well, it couldn't hurt this once. And besides, you don't want to do that. You want to get into consistency. If you're using an unprepared statement in one place, a prepared statement in another, a different technique all over the place, you've introduced potential failure points through inconsistency. All right, so I've got my, now, how many records are you expecting back here? You used a director ID, right? 1 What if it fails though? What if I have a director ID of 42? So director D is equal to get director by ID negative 42. Probably doesn't exist. System.out.println D. All right. So what should, how can we detect that? Right? Well, we can use an if statement instead because we're expecting at most one. Right? If RS has next, then process it. Right? Else, there was 0 in there. Right? So if there was 0 in there because you said director negative 42, right? How do we handle this? How would you handle this? Say what? Oh, okay, I could return null. Do I want to immediately return null? What should I be doing after this or before I go back? rs.close, ps.close, con.close. And if I immediately return, then this doesn't get executed. Right? I've got a resource leak. So I'll go ahead and change the pattern a little bit. Director D is equal to null. And if I want to return null, then instead of returning, I'll just do nothing. D is equal to null, right? Now, if I were to do this as a design decision, of course, I would just get rid of this entirely because this is a do nothing else statement. Right? Ultimately, we're going to return D here. Let's close this off and catch that SQL statement there, or that SQL exception so that it actually compiles. There.
Where do we set D to not null?
Here, we're not done yet.
Oh.
What's an alternative, though?
Shut them down.
Shut them down, okay. Like, throw a new illegal state exception. How did you get that ID to begin with? Right? Presumably, you queried it out of the database and found it as a foreign key, right? Then something really wrong happened because you have supposedly a valid ID, but that doesn't correspond to a valid record. Maybe it got deleted between you asking for that record, got deleted, then you asked for the director ID, right? It's an illegal state. So, cannot find director with ID equal to plus director ID. Not only that, but it's much more helpful information. Rather than just failing silently with null, I don't know what you're talking about, right? Now throw it back to, I don't know what you're talking about because you asked me for this, it doesn't exist, and here's the information that you can use to troubleshoot. Right? We'll talk about how to do this even better later on. Two options. I'll go ahead and leave it as null for now, but I'll make sure that it's in there in the notes. When I run this, of course, I still get null for negative 42. I'm getting null everywhere else because we haven't finished it. Process it means get its first name and last name. So string first name is equal to rs.get string first name. Same thing for last name. And then I can create a director. D is equal to new director with director ID, first name, last name. And if you don't want to save these off into variables, you can, of course, go ahead and call the getters directly in here. That leads to very long lines or very long lines that are broken up. Stylistically, be consistent. Right? I like putting them into variables here because it makes debugging so much easier. If you can stop on this line, there's something wrong with this line in particular. If that was all just one big giant line, you wouldn't know what part. Okay. Let's troubleshoot this, see if it works. Still getting null, but now we're getting David Lynch, Quentin Tarantino, and J.J. Abrams. Excellent. Right. And it's all because we just wrote these two methods. Yeah.
Still getting null.
Well, that's this right here. There is no director 42, negative 42. Right.
Okay.
Oh, and OBS got way better. So hopefully it's okay. Questions so far? No? We've only got 15 minutes left, but just to review here, I guess. Make a connection to your database, formulate your query. Here, I'm going to replace this with this. Prepare your query, and then execute your query, and then see process your results, right? For select statements. Haven't done insert statements yet, right? We will do that next week. All right, and then finally, most importantly, clean up. Close your resources. Okay, so we'll come back and do a little bit more on this stuff, but I do want to mention the best practices that I've already mentioned. The first one, of course, is dealing with SQL exceptions. That unfortunately most operations have a checked SQL exceptions. How do you deal with SQL exceptions? You catch and release. So just catch it and rethrow it as a runtime exception. Right? Now, some people ask the question of, well, can I just do it in one big giant try-catch and then put everything in there? Yes, you can. If you want fine-grained control over what happens, though, then you need to have a series of try-catches. That's a design decision that's left up to you. You may even want to log the error and then rethrow it, right? Because that's valuable information. Right? Where was that version that we had? Here. Cannot find director with director ID, blah, blah, blah. Right? Why wasn't it in there? Right? Now I need to go back and troubleshoot. Oh, okay, well, it got deleted in between, or I've got a bad SQL query, whatever. Troubleshooting, right? If I'm just doing stuff like this, for example, system.out, out.println, error, right? Or bug. Well, if I just left it like that, that would be really useful, right? Sarcasm. That's not really helpful at all. So provide that. And if I just use the standard output, or the standard error would be even better, right? Cannot find director with ID, whatever, right? And I get it in nice little red text here. But in real life, in real applications, nobody's sitting there staring at the console waiting for something bad to happen, right? But you do want to know when something bad happens. So you want to use a proper logging system, where you've got a logging system that first of all, you can define different levels of logging. The most critical are going to be errors. You want to know about all the errors. Another tier might be just warnings. Well, it wasn't fatal to the system, but warning, OBS ground to a halt at 3 o'clock today, right? It didn't kill the stream, but it might want to check into that, right? It might want to call ITS yet again to tell them that the network transition sucks. You might have another one where it's not a bad thing at all. It's just information. So-and-so logged in today at 3:30, right? For auditing purposes. You want to know when people were in the system, when they were not in the system, right? I show you logged, I do this all the time with a grader, right? We had some real problems with our assignments. Oh, okay, I'll check the system logs here. Looks like you only turned it in like 5 minutes before it was due. So you were working on it all week? I don't think so. That's the kind of information, right? That helps with auditing. Then you have like lower level stuff like debug information, where you just print out every single thing that your program is doing. But when it goes to production, you shut that off because you don't want debug information in a production system. A proper logging system using a proper logger would allow you to do stuff like that. Not only that, but it would give you other advantages, like, for example, all errors should go over to this file over here. All warnings should go over to that file over there, so that they're all separate. And by the way, when errors happen, also email me about it, or persist it to a database, or do any number of things that I want you to do over there. Yeah.
What type of logs are stored?
You could define that exactly. In fact, the one that I'll show you next week, log4j. We'll just go with the standard formatting, but you can format it in any way that you want using the configuration file. So that's another advantage, and that's another feature that a proper logging system would allow you to use, so that it's easily greppable, it's easily searchable. Another feature that a logging system typically gives you is rolling log files. So suppose that you want all files in one, or all logs in one day in one file. You don't want doing big giant God file for the last 30 days. So what it can be set up to do is log everything for 24 hours. At midnight, roll it over to a new file. At midnight, roll it over to a new file. So you've got this sequence of files, these 30 old files. At the end of 30 days, this is completely configurable, so you can keep logs into perpetuity if you want. But otherwise, at the end of the month, at the end of the 30-day cycle, it'll automatically delete the oldest one, right? And then start a new one. Or you can make it on an hourly basis, right? Especially if you've got a large system, lots of logs. Or you can make it on a file size basis, right? Fill up 100 megs of logs, go on to the next file. Fill up another 100 megs, go on to the next file. Delete the last, only keep at most 10 so that we only have 1 gigabyte at most on the system at any one time taking up logs. Otherwise, if you have every log set on and no way to delete it, your system, depending on how busy it is, will immediately fill up and your disk usage is done, right? In fact, that you might have experienced that on the grader before, right? If you print out too much stuff and it comes out with a PHP error of 136 or 137 million bytes used, you filled up the PHP log basically, and then okay, I can do no more, error, nope, no more. You used 137 megs of output. Good on you, but you did it like immediately, so at least you did it fast. Again, always use prepared statements. Prepared statements allow an SQL injection, and I'll show you what, I showed you what it looks like, that you can end an SQL statement and then begin another SQL statement. And if it's a simple, concatenation, and you've got your server set up so that it is, you're allowing compound SQL statements to execute, then you've just lost your student table. Yeah?
You see the picture where someone on a member plate in a car put database?
Excellent. Yeah, that's a really long license plate, though.
Yeah, it was like the bumper and the camera shot him.
Oh, okay, so it was kind of a joke, hopefully, right? It didn't really actually happen. Oh, okay. Yeah, you can design malicious QR codes, right? You can do a whole bunch of things if you're not sanitizing data and protecting yourself. There's also, if you do it in Lab 9, I believe, it takes you through how to do an HTML injection attack, where you can make say, let's take Facebook because I think it's secure, but suppose you put a post on Facebook and then you put in some HTML, right? And then you save that to the Facebook servers, and then when it gets served to your friends or people viewing your profile, instead of your message, well, your message will be received, but then also it'll start formatting stuff in HTML. And, oh, click here for to reset your password or something like that. Somebody clicks that, and you take them to your website rather than Facebook, right? Because you were serving that HTML. Now think about not serving up HTML, but directly serving up JavaScript code. And then you don't even need them to click at all. You can execution on whatever insecure platform that's not escaping that kind of stuff. Or sanitizing is another term for it. Especially on websites. You see it all the time, right? So always use prepared statements as far as SQL are concerned. Never use anything else, period. It's just, don't even go down that road, right? We also talked about avoiding the star operator. And this is where we'll end it today here. It brings over all the data even if you don't use it. It brings over redundant data if you join together things and there are multiple Quentin Tarantinos. You'll end up wasting bandwidth and making the connection way slower. And you ultimately ignore at the endpoint. So don't do that. It also protects you against changes in the database. Right now, we're only querying metadata about films. Suppose that somebody starts storing MP4 files with the actual films in the database. Not a great idea to begin with, but now there's a 4 gig file blob, binary large object, in our database. And if we're using the star operator, we're pulling those megs, even though we only wanted the title of the film to print the title, right? So it protects you against changes in the database if somebody happens to come along and add more fields, more columns, and especially large columns, right? So be intentional always with all of your code. Okay. We'll pick it up with more another example and more tips on Tuesday.